Welcome back to another episode of T.E.D Mini, where together we'll be learning about technology, engineering and design. In today's episode, we'll be exploring how resistors in series and parallel work. In the last episode, we have already spoken about how resistors work and the different types of resistors available. For today's episode, we'll be using fixed resistors to keep things simple and understand how to calculate the resistance when placed in series and in parallel. So why would there be resistors in series or in parallel, you may ask? Well, the reason may be twofold. It may be that the exact value of resistor that you need does not exist, and so you may need to combine two resistors together to get the desired total resistance. You may also need to divide voltage, but we'll get to that in another video. Let's start by looking at resistors in series. Having resistors in series means that electricity will flow in from one side and will have to pass through each resistor one after the other. We'll label these resistors as R1, R2, R3 and so on. The equation to calculate the total resistance in such a circuit is quite simple. The resistance total, or RT for short, is equals to the sum of all the resistors in series. So if we had 3 resistors, RT equals R1 plus R2 plus R3. Let's take an example. If we have 4 resistors, we start by first writing down the equation. So RT equals R1 plus R2 plus R3 plus R4. As we do not know the resistance total yet, we write RT right underneath it. Then, we replace the letters representing each resistor with the resistor value. So if R1 is 100 ohms, we replace R1 with 100 ohms. And so on and so forth. So R2 would be 220 ohms, R3 would be 470 ohms, and R4 will be 520 ohms. As we can see, on this side of the equals we know all the values, so we can add these all together mentally or using a calculator. And the total, which is 1310 ohms, is the resistance total. Always remember to include the units of resistance. 1310 means nothing on its own, it would be just a random number, so always add the units. Since we have our answer, we just need to double underline and write the letters A and S, short for answer, right next to it. Why, you may ask? Remember that examiners are correcting hundreds of papers. If your working is messy, or you've corrected your working a couple of times, they may mistake another working or number as your answer. By drawing attention to your answer neatly, it improves your chances in an exam, as well as makes all your workings much neater. A quick hint. 1000 ohms makes 1 megaohm, so in the case of our answer, we can go one step further and convert our answer from ohms to megaohms. If we divide our answer by 1000, it is converted to megaohms. Be careful to write the symbol for megaohms properly. It is a capital M, not a small m. Now let's look at resistors in parallel. Resistors in parallel are a little more complicated than this. The equation for resistors in parallel is the same as that of resistors in series, but everything is inverted and has got a 1 all over. So now, if we have only 2 resistors, the equation is 1 all over RT is equals to 1 all over R1 plus 1 all over R2. It is very important to put down the brackets and first work the values in those brackets. So as we have done before, since we still do not know 1 all over RT, we shall write it down again underneath the first. Then we'll replace each resistor symbol with its resistor value. Next, we'll work the maths inside the brackets, and once we have the answers to each one, we'll then add both values together. However, that number is still not our answer. Remember that on one side of the equation, we do not have RT equals, but rather 1 all over RT. We need to remove that 1 all over. As you know, we cannot divide number by letters, so we need to change the subject of the formula by moving all of the numbers to one side of the equation and leaving the letters alone on the other side. For those of you who do not know how to make a subject of the formula, I will quickly explain how to do it very simply. For those who do know, you may want to skip along. When moving numbers or letters from one side of the equation to the other, it is like they are changing parties. For example, if a Labour Party member is changing side, he would go to the opposition, which is the Nationalist Party. If a plus or addition sign has to change sides, it would become its opposite, the opposite being a minus or subtraction sign. A subtraction on moving side would become an addition. The same with times or multiplication and division. back to our own equation. So in our case, we have 1 divided by RT. If we had to move RT to the other side of the equation, as the RT is a division, once it moves to the other side, it will become a multiplication. So now we have a number on its own on one side, and on the other side, our working multiplied by RT. The next move is to place our working on the other side of the equation, so the numbers are together. As our working is now a multiplier, when we change sides, it will become a division, so 1 divided by our working. As all of this side of the equation is now made of numbers, we can now divide 1 by our working, and the answer will be equals to our total. Next time round, you can skip these last few steps and just replace our working with RT, as you now know how to make a substitution. But we're not done yet. Don't forget to double underline and write A and S next to your answer. And that will be all for today's episode of Resistors in series and in parallel. I hope you enjoyed it, and if you have been, thanks for watching.